Hi everyone, in this video we're going to start learning about loops, and we'll start with while and do-while loops. So loops are useful when we need to repeat some process over and over again. So as an example, we're going to start off by computing the factorial of a number. So let's just go ahead and take a look at the C program that we're going to be building. So in this program, like I said, we're going to compute the factorial of a number. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. So it's always just going to be the number times everything less than it. So to use our while loops, we're going to need what we call a loop control variable. So this is the variable that's going to tell us when to when to stop our loop. And we will use I here. And in this case, let's just start it at 1. And to start off, when I am building a program that uses a loop, just like when I'm writing all my programs, I kind of want to build this incrementally. So first, I like to just start off by making sure that I can get a loop working over the variable values that I want. So I will just write a quick while loop here. So we say while, and then we're going to say while our loop control variable I is less than or equal to 5, because in my comment there I said I want to keep going until I'm going to say I do want 5 here. So maybe my gets to 5 is a little imprecise, but I do want I to take on the value 5. So as long as I is less than or equal to 5, I would like to, just for now, let's print out I. So use my placeholder, and I'm going to want a new line there, and I'm going to print I. And then what I'm going to need to do in this loop is increment I, so add 1 to I, so that we get closer and closer to 5, and eventually I is going to take the value 6, and we won't go back into the loop. So let's just take a look at this, compile it, and run it. And so what we wanted was I to take the values 1 through 5. And that is what we got. So let's just look at this again and see if we can understand that. So we said while I is less than or equal to 5, we're going to print out, I'm actually going to say I equals here just so we have even more information when we print it. And then we're incrementing I by 1. So each time this goes through, we print, and then we increment I. So what we really want to do, though, is not just print I from 1 to 5, but we actually want to compute our factorial, right? So let's also define a variable for ourselves for that factorial. So when we are doing something like this, where we are computing something by looping, we call the variable that we use to keep track of that an accumulator variable. So in this case, we're going to be multiplying, right? We want to multiply 5 times 4 times 3 times 2 times 1. In other cases, we might be adding. Like if I wanted to compute the total of something, I would have to add every time I go through the loop. So let me initialize that. And for multiplication, I need to initialize at 1, right? Because I need to multiply 1 times 2 times 3, etc. If I were adding, I would probably want to initialize at 0, right? So I could add on. So let's see here. So every time I go through, the first time I go through this loop, I is going to be 1, right? I haven't incremented it. So I would like to, the first time, I would like to multiply fact times I. The second time I go through, I is going to be 2. And that's great because I need to multiply by 2 as well. The third time it's going to be 3, etc. And so I can just set fact to be whatever fact times I is. And let's also print out fact, just so we can make sure everything's going how we want. And that looks right to me, so I'm going to compile again and run. And okay, 5 factorial is 120, so that looks good. And just like we hoped, let's see, things start getting interesting after 3, right? So I was 3, and we multiplied whatever fact was before times 3, and we got 6. So that is looking good. Now, oh, I compiled, but I wanted to take a look at my file again. So our goal was actually to just compute the factorial of any number. So let's actually get that from the user. So we do that. We're going to need n, and we're going to need to ask the user for a number, enter a, let's say, positive integer, and then we use scanf to get that from the user. So D is our placeholder there, and we need to pass in the address of n so that we can save whatever the user enters to n. And now, instead of looping until I gets to 5, let's loop until I gets to n. And now we can compute the factorial of whatever our user enters. So we're going to compile that and let's run it. So let's just check that it still works for 5. That looks good. What happens if we run 10? Well, it's definitely a lot bigger by the end, right? But we did the same thing up to 5, but we just kept going all the way to 10. So those are the basics of our while loop, but let's go back into our factorial program and use some fancy ways to increment our variable. So let's take a look at factorial. So if you have programmed before, you probably know that instead of, this is sort of the long way to write increment I by 1. So increment I by 1. We can also increment I by 1 by saying, actually in multiple ways. So one way we can do it is we can say I plus equals 1. And that just says exactly the same thing. It says add 1, set I to be whatever 1 more than I was. And let's see, we can see that over here. So we call these compound assignment statements. We can do it with all of our arithmetic operators. Honestly, I would say I almost never use divide equals or remainder equals, but if you have a reason to use them, you can. So I can do the same up here, right? So I just wanted to set fact to whatever fact was times I. So the shorter way to do that is fact times equals I. So set fact to fact times I, and that's what that does. So let's just, we can always make sure that we haven't made any mistakes by rerunning our program and making sure that it's still doing what we expect. And indeed, I was not lying to you, these compound assignment statements work. So in addition, I can also use an incrementer operator. So if I just want to increment I by 1, I can write I++. And again, that's just going to do the same thing. It's going to set I to whatever I was plus 1. And again, let's just run this. Oops. And everything is still working. So that is I++. So however, in C, I can also write ++I, and that will also work. And in this case, well, if it's just a single executable statement, then writing ++I and I++ does exactly the same thing. We can see that by just running our program again and seeing that there's no change. However, those two are actually different. So let's take a look at my inc.c program that I have written here. So the big idea, so this program is just initializing some variables. So we have an integer m that's equal to 10, an integer n that's equal to 10, and then we're also declaring an integer p. So we're going to set that later. And so we just have two ways to set p here. In the first one, we are putting our ++ before the m, and in the second one, we're putting our ++ after the n. And so I've written in the comment the difference between these. So if my ++ is before, then I'm going to evaluate ++m, actually execute this statement before executing the rest of the statement. If it's after, I'm going to actually execute this ++ after the rest of the statement. And so what does that mean? It means, so m was 10, after the ++, m is 11. Maybe I'll say. And so 11 plus, so p is 11 plus 5 is 16. So in the first one, p is going to be 16. In the second one, it looks almost the same, but I'm only going to do this ++ after this entire statement is executed. So n was 10, well, n is 10. We're going to do n plus 5. So n, okay, p is n plus 5. Oh, p is 10 plus 5, right? Because p is n plus 5. And that's going to be 15. And then n will be set. And then after ++, n is 11. So in both cases, after this statement executes, m is 11, and here n is 11, but p is different. So let's see this actually run. We're going to see, we need to compile it. And then let's run it. And so just like we said, in that first case, p is 16, in the second, p is 15. So it's worth just experimenting with this on your own when you're writing your programs to understand it, because if you don't understand it, it's going to be really hard to write programs that do what you want. And this will definitely be on the quiz. So finally, in addition to a while loop, we also have a do while loop. The only difference is that we do what's in the body of the while loop before checking the condition. So let's go look back at our factorial. So in a while loop, what do? We check condition if true, execute body. So this is inside here, this is the body of while loop, and this is our condition. But in a do while loop, we execute and then we check. And so let's see if we can rewrite our factorial problem using a do while loop. So we still want to stop when we get to 5. So, while but here, because we're only going to check afterwards, we can set our check. We're going to need a slightly different check. So let's copy over our same body here and comment out this part. Oops. Oh, I forgot to put on my key casting. Maybe that's easier to see. I don't know. But okay. So again, we want to loop until I gets to n. So it's useful to think So clearly the syntax here, I forgot, was we put our do, So we've got our do, and then we have the body, so this is what we want to do, and then our while goes after, and then we do need a semicolon after this, our loop variable. So we're going to execute this once no matter what. So that's basically the thing about the do while, is we're always going to execute this body, whereas in our while loop we may not, because if the condition starts out as false, then we won't execute it. So one thing we could do is just run this and see what happens. So I guess that might be a little far up there, so I'll just rerun it. Factorial, let's see. And let's just use our trusty 5. So in this case, we're only going up to 24. Oh, because I changed that condition. So it turns out we still need to go to less than or equal to 5. It just checks it afterwards. So now we're back up to our going all the way through 5. And so the big takeaway for our do while loops is we're always going to execute the body once, and then we only check the condition afterwards. And so that'll be it for while and do while loops.